Good day everyone. Today we're going to start with chapter 7, quadratic equations. Before we're going to start with paragraph 7.1, I want to quickly tell you what we will be learning during this chapter. They start out with paragraph 7.1 that I'm going to talk about today, and that's mostly about number types and what prime numbers are, which is very interesting indeed. But the most important part comes after that. We're going to take a look at what factorization is, in Nederlands ontbinden in factoren. And we're even going to take a look at how we can do it in 3 different ways. This is going to be very important because this will help us solve quadratic equations. We already know one way to solve a quadratic equation from chapter 5. We're going to learn a few other ways as well. And we need factorization for that. We're going to take a look at how to solve quadratic equations with brackets and how to calculate the points of an intersection of a parabola and a line. And the plus section we're going to take a look at how we can prove theorems on numbers. But let's start with the first one, which is properties of numbers. To introduce you to this subject, I would like you to take a look at this question. Can you divide 48 pence fairly over 2 students, 3 students, 5 students, and 7 students? And if you know the answer, how have you calculated this? Well, if we're going to take a look, I can go to the next slide, and we'll see we can only do this fairly for 2 and 3 students. We cannot do this for 5 or 7. I think most of you would take a look, well, can I divide 48 by 2 and get in this case, a natural number, a whole number? You could also say, well, it's positive in this case, out of that answer. We can do that for 2, 48 divided by 2, 48 divided by 3. But if I try to divide 48 by 5 or 7, I will find a fraction. Why do we need to know this? Well, we're going to use this knowledge as a way to take a look at the properties of certain numbers. The book says for any natural number a and b, remember a and b are placeholders, they can be any numbers, b is a divisor of a if the result of the division a divided by b is a natural number. And divisor in this case means een deler. So, for example, you could also say in a more easy to understand English sentence, you could say that the division gives a positive whole number, also known as a natural number. 2 is a divisor of 12 in this case, because 12 divided by 2 equals 6. 3 is also a divisor of 12, because 12 divided by 3 is 4. But in this case, 5 is not a divisor of 12, well, because we all know this is 2.4 and this is not a natural number. Or you could say this is not a positive whole number. That's one of the properties that we're going to use. The other properties that we're going to take a look at are how we define even numbers and odd numbers. And I think we already know how to do this. Now we're going to say, well, how do we define them? The even numbers are 0, 2, 4, 6, 8, 10. And the odd numbers are 1, 3, 5, 7, 9, 11, etc. All the even numbers, alle even getallen, are divisible by 2, and all the odd numbers are not divisible by 2. Okay. Well, there are other rules that we can use as well. A natural number is divisible by, for example, 3, when the sum of the digits is divisible by 3. Okay, how does this work? For example, 18. That one consists of a 1 and an 8. If I add them together, the sum of those digits, it gives me 9. 9 is divisible by 3, so 18 is as well. Another example, 132 are the digits 1, 3, and 2. Add them up, gives me 6. 6 is divisible by 3, so 132 must be as well. I'll also give you a counterexample, right? If we're going to take a look at 28, that's 2 plus 8 is 10. Well, 10 is not divisible by 3. It does not give me a nice natural number as a result. So, in this case, 28 is also not divisible by 3. The next one, 4. When is a natural number divisible by 4? When the last two digits form a number that is divisible by 4. So if I take a rather large number like 1116, I only have to take a look at 16. 16 is divisible by 4. If I know that, then 1116 is divisible by 4 as well. So in this case, I'm not taking a look at the first two digits. If I'm taking a look at 80, well, I only have two digits, so I have to take a look at 80 in this case. 80 is divisible by 4. Yeah, okay, then 80 is divisible by 4. Okay. Another example, counterexample, 134. I don't have to take a look at the first digits, so I have 34. 34 is not divisible by 4. So 134 is also not divisible by 4. I think 5 is a rather easy one. 5, a natural number is divisible by 5 when the number ends on either a 0 or 5. So only take a look at the last number. 75 ends with a 5, so it's divisible by 5. 15,730 ends with a 0, so it's divisible by 5. 142, counterexample, ends on a 2, so it's not divisible by 5. Okay. Then 6, you should take a look at two rules. The number should be even, so divisible by 2, and it should also be divisible by 3. So for example, 30 is even and divisible by 3, so 30 is divisible by 6. 132 is even and it is divisible by 3. How do I know that? Yeah, remember the rule for 3, right? I add up the digits, I get 6. 6 is divisible by 3, so 132 as well. So 132 is also divisible by 6. Now I give you two different counterexamples which counter different things that can occur. 45 is divisible by 3, but it's odd. So in this case 45 is not divisible by 6 because it is odd. But it can also be the other way around. 142 is even, right? So that's the first thing that it should be, but it's not divisible by 3. Both things should be possible. So in this case 142 is not divisible by 6. And then the last one I'm going to take a look at is when this something is divisible by 9. Yeah, then the sum of the digits is divisible by 9. So just as with 3, you add up the numbers. In this case, if I get something that's divisible by 9, then the whole number is divisible by 9 as well. So 18, and in this case 2,349. For 208, add 2, 0 and 8 gives me 10. 10 is not divisible by 9, so 208 is also not divisible by 9. And then the last thing I want to talk about are prime numbers and prime factors. We already kind of shortly discussed what prime numbers are in first grade. A natural number is a prime number when it has exactly two divisors, 1 and itself. Right, so there are an infinite number of prime numbers. The first prime number is 2, 3, 5, 7, etc. Try it. You cannot find different divisors for 3, 5, 7, etc. It's only 1 and it's the number itself. Well, if every number that is not a prime number can also be written as a product of prime numbers. We call that the product of prime factors, priemfactoren. In Nederlands, elk nummer dat geen priemgetal is, kan dus worden geschreven als een product van priemgetallen. We noemen dat product de priemfactoren. So for example, 8 is not a prime number, can be written as a product of prime numbers. 2 times 2 times 2. For example, not 4 times 2, because 4 is not a prime number, right? If I'm going to write it as prime factors, I want to be able to write it in only prime numbers times each other. 2 times 2 times 2. 60, not a prime number, can be written as 2 prime number times 2 prime number times 3, which is a prime number, and 5 as well. So this thing is called the prime factors of 60. Try this for 42. How would you start? Well, I would always start by first taking a look at, can I divide this by 2? In this case I can. then I'm left with 21. 21 I cannot divide by 2, but I can divide it by 3. And then I'm left with 7, which is a prime number. So 42 is 2 times 3 times 7. And accidentally I already showed 49 in this case as well. Start from the beginning, right? You cannot divide it by 2, you cannot divide it by 3, you cannot divide it by 5. Hey, 7 is next in line, I can divide by 7, and then I'm left with 7, which is a prime number. So 49, the prime factors are 7 times 7. And that was everything that I wanted to talk about for this paragraph, properties of numbers.